Um, Welcome, everybody. I'm William Horton. This is Demystifying AI Agents with Python code. So the first question you might be wondering is, who am I and why do I care about AI agents? Well, the first answer is I do not work at Bloomberg. No offense. Who am I? I'm passionate about applying GenAI in healthcare. Over the past 2 years, I've been working at a company called Included Health to build out our platform for building applications on GenAI. And I recently started a new role at a company called Maven Clinic, which is focused on women's health. And if you look on social media, you can find me. Twitter, I'm at Horton. Here's a foo. Blue Sky, I just really needed to have it. So I actually bought here's.foo as a domain because they do domain verification there. So second question, what are AI agents? Sometimes I think the best description comes from Blades of Glory. No one really knows what it means, but it's provocative. And I can tell you, mentioning AI agents does get the people going. But more seriously, people are still grappling with this question of what is an AI agent. So this was a tweet from Simon Willison, who people in the Python community might know as the co-creator of Django. He's now, in my opinion, one of the best writers about actually applying LLMs as well. And he made a tweet to see, can we gather a bunch of definitions of agent and see what people agree on? My favorite one was probably this one, Princess Bride. But more seriously, the definitions started to kind of approximate different things that people could agree to on agents. So the first one's from the creator of LangChain, saying it has something to do with the LLM deciding the control flow. The second one is from the creator of Crew AI, which I'll demo later. And it's saying like the LLM is making decisions. But personally, this was my favorite. So Swix is the founder of an organization called AI.engineer, and they host different conferences. But it's very simple. Agent equals LLM plus memory plus planning plus tools plus while loop. And it was actually that last part that kind of inspired this talk, because I'm like, while loop, I mean, that's something that a lot of people in this room have written. It makes the concept of AI agents less scary. And if we break down the other pieces in the same way, I think that we can better understand it. So this is going to be the foundational definition for this talk. Another question is it all just marketing hype? Like, is it just something people are using to sell us stuff? And the answer is, like, I think so, actually. I think AI agents are currently overhyped. I think a lot of people who say it, frankly, don't know anything about what they're talking about. But at the very core of it, I do think there is a useful functionality. I think that LLMs plus tools doing some of these things is going to continue in the future and be developed into something that is valuable, at least in certain use cases. And so it's worth exploring. And so my real hope in this talk is to show you how to cut through the high-level marketing terms and understand, okay, when someone says memory, which is kind of vague, like what would that actually look like in Python code that you can understand and even that you can write? That's the real main goal of this talk. And so without further ado, I'm going to go over to the code, because I know sometimes looking at code on the screen can be challenging, annoying. I did make a link to a repo that has this notebook that I'm going to be walking through. So you can follow this link or scan the QR code. It's bit.ly/agents-PyTexas. And I'll take just a minute to let people go to that if they want to be able to better follow along with the code that I'm going to be showing in this notebook. Okay, I'll give it a little bit more time. If you don't have it, get it from your neighbor. So switching it over, so this is a notebook I wrote for this talk, and I've written our definition here. So LLM plus memory plus planning plus tools plus the while loop, crucial. So the first thing is LLM. I think, okay, hands up here if you've ever interacted with an LLM. Like it's at this point, it's most people, like most American adults, especially software engineers, have used an LLM. A lot of people have used it in this way. So you go to a UI like ChatGPT, you type in your message, it gives you a message back, you can have a conversation with it. So the first step in understanding AI agents using Python code is to understand how we could replicate that experience using Python code. And I'm going to show you using the OpenAI SDK. That's what I'm familiar with. But most providers have their own SDK that has very similar functionality if you use Google Gemini or if you use Anthropic. A lot of this stuff will be applicable. They even sometimes have OpenAI compatible APIs. So this would broadly apply to the different kinds of LLMs you'll encounter. So we can instantiate a client to OpenAI. And we can use this endpoint called chat completions, which is represented here. We send a user message, and I said, for this one, tell me about the Python programming language in a few sentences. And we can send that to the LLM, and we get a response. And the response is kind of complex, but what we really care about is this content field. And so in our code, we can pull that out and print just the text. Print just the text that it gave. And this is like a decent summary of information about Python. So this is the base level that we're going to be building off of. We were not going to go deeper than this. If you wanted to, you can, and that's probably a whole nother talk, but we have to start at some level of abstraction. So we're saying, we have this client, it's going to call an LLM and give us something back, and we're going to build from there to AI agents. Another important thing to know about LLMs is what's called a system prompt, or OpenAI is using developer prompt. You can give it instructions, which can be humorous, like this one. I said in the instructions, talk like a pirate, and they asked the same question. Now we get a description of Python in pirate language. One last thing to know is that there's a hierarchy of how it follows these instructions. So if I say talk like a pirate, and then I say in the user message, don't talk like a pirate, it's actually going to follow the system instruction first. That doesn't apply to all models, but this is something OpenAI has started doing to avoid problems like prompt hacking. And so it's going to follow the system instruction even if it's the user tells it not to. So we've got LLMs. That's kind of our first base piece of an AI agent. Memory. This is a problem that comes up. Everything I just showed you is stateless. And so if I wrapped it in a function that said call LLM and use the API that I just demonstrated, my name is William. OK, great. What is my name? I can't tell. Like that's not that useful. For a lot of things, you need memory. And so the API, the way that it does it is you can pass messages as a list. And so as you accumulate messages in your conversation, you just continue to pass back those messages in this list. And so if I wanted to continue the conversation about Python programming, I would first send back the text that the assistant is the representation of the model. I send back the text it sent me, and then I send my own question on top of that. And this is saying, I asked you a question and you answered it, and now I want to ask another question, and I want you to know that we're having this conversation. And so if I do that, scrolling, it should follow up with elaboration on Python use cases. And if we took that concept, we could put it into a relatively small stateful class where we say, we're starting with the list of messages. When we get something from the user, we put that into the list. We get a response from the API. We put the response into the list, and then we send the user the result. So adding this memory part, I can say my name is William, and then I ask, what is my name? And it knows what my name is because we're tracking this piece of state. And memory can be very complex beyond that, but really this is like the basis of it is just keeping track of the user's messages and making sure we send them back to the API when it's necessary. So the third part, planning and tools. This is probably the most complex part. It's the part I'm going to spend the most time on, but I also think it's the most interesting. So let's say that you want an LLM to call a Python function that you've written. Why? And one note is tool and function. Earlier on, people used function. A lot of the providers are switching to tool. People still use them somewhat interchangeably. I probably will in this presentation. Strictly speaking, in OpenAI's terms, a function is like one kind of tool, and there's other kinds of tools. But I just want to say like they're kind of the same thing, honestly. So if I have a question, who is currently leading the masters? What do people think it's going to tell me if I ask it this? This is just asking like the LLM API. And see, this is actually this is an improvement on what older models used to do. It tells me it doesn't have real-time data. This would often cause hallucination in older models because it would think like whatever the latest training data is, I'm going to tell you that. But you can see this is a problem. It has no idea because it's not connected to any real-time sources. It only has the information that was in the data it was trained with. But using Python, I know that I can write a function that would search the web for a given query. So this is using an API called Serper, as well as the request library. And I take in a query, and I search, and I send back the results. And this function, I do want to emphasize, this function has nothing to do with LLMs. And you can use this function without the LLM. Like I can just call it, and it will give me results about the masters. So now that I have this function, and I can show that I could use it manually to call the web, how do I get my LLM to use it? And kind of building off the first part, we know we can give instructions to the LLM. So what if we just told it that it has access to this function and tell it a specific syntax to use whenever it wants to call it? So in the system prompt or the instructions, I've done that. And now I'm going to do the same thing, but I'm going to ask it that. And well, now you see one problem with LLMs. The query that it came up with is 2023, because for this particular model, that's when it stopped training. So just a tweak I have to make is in the instructions, I'm also going to inject the current date time. And this can be very useful in a lot of settings, but here it'll be good because it won't think that it's trying to search in 2023. So with that slight adjustment, I call it again, and I say, who is currently using the masters. Now it returns this syntax that I said use this syntax to say call the function. And so I can use a regular expression to now extract what it's telling me to use as the query, which is this string inside of the search web function. And I can call, the strings from the previous run. It's not totally deterministic, which we'll talk about, but I can now run that against my search function, and we basically get, in total, this way of getting the LLM to use a function, which is, in the instructions, I tell it has a function, and I tell it what the schema of the function is. When it gives me a response, I extract with a regular expression the function and the parameters it wants me to use. I actually run the function for it, and then I pass the results of searching the web back to the LLM. So now it has access to this string that was generated. And using all of that together, it can formulate an answer, hopefully. We'll see if this works. So you can see here, I hope that's accurate. I haven't checked the leaderboard. Really? Okay. Well, that's a problem with outdated data here. So yeah, you can see the last part here is the important part. I say, here are the results of search web, and I actually send it the string that the function gave me, and it can use that data to give me more updated results, although apparently still outdated. But this process can be like a lot to write yourself. And so thankfully, the providers have given you a structured API to describe functions that you want to use, and in addition have trained the models to recognize this specific syntax. And so you can describe your function in this way. This is OpenAI spec. There's a lot of boilerplate, but essentially I'm saying I have a function with this name, with this parameter, and these types. And so now, instead of passing it in the instructions, I pass it in a separate field called tools. And that is doing the same thing, but now using the API that the provider has given me. So hopefully it'll perform better in more complex use cases. So the output is now also structured, and you can see inside of it there's this function object which has the name and the arguments, and that makes it a lot easier to extract the parameters compared to like this kind of made up syntax I was using, which isn't structured. I had to use a regular expression. When you use the provider's API, it's all given to you in a dictionary. So we can just load the arguments. We can see that it asked me that. We can search for results in the same way. And now we can pass it back. And the difference here to note is when you're using the providers API, there's a new kind of message, which is a tool message. And that is the message you use to send back the results of the tool you just used. And it also, importantly, has an ID, which allows it to link back to the function it asks you to call. So basically, your contract with the LLM API is saying, if the LLM API tells you to call a function, it gives that an ID. And so whenever you pass the result back, you mark it with the same ID, so it knows that that's the response to the function call. And that can be, it's not like so necessary in this where we only have one and one, but it can be more complex. The LLM can ask for parallel function calls or can ask for one after another. And so that's just one way that the API keeps track of what you're trying to do. And this is another important note. It doesn't have to use the tools if it's not necessary. And that's where you start getting into, it has some form of planning. It knows it has been trained to use the tools when they're most appropriate and not use them when they're not appropriate. So if I ask it, write a haiku about Python programming, it didn't call search because it can just do this out of nowhere and it doesn't really need anything from the web to be able to write a Python haiku. So it just does it. So this part is just a little bit of, if you're very into Python internals, this part could be fun, but you notice I had to manually define this tool spec. But it turns out, since in Python functions are also data, we can use the inspect module to go from the function directly into this tool spec. This is like a little bit complicated, but essentially we're getting the signature of the function. We're mapping the type into a type that's used in OpenAPI format. We're mapping the default values. We're mapping the name of the parameter. And then ultimately we're returning this object. And so running that over our function looks something like this. And we can also check this function I wrote, is it equal to the thing I defined manually? And it is. So yeah, that's definitely one you can go back and look at if that's something that interests you. I find it very interesting, but it gets a little bit nitty gritty with the internals of function properties in Python. But putting this all together into how does an LLM call functions or tools, we can have a that's very meta. We have a function now, call them a tool calling. We pass a message and the functions we want to use. We map from the name of the function to the actual implementation. We send the messages to the LLM along with the definitions of our tools. We see, are there tool calls or not? And then this is where like people will talk about agents are just a while loop. And this is true because this is the heart of what an AI agent is, which is saying, you send a message to the LLM, and essentially there's only two things, in this case, we'll limit it to two things it can do. It can send you back text, or it can send you back a response that tells you call a tool. And so if it sends you back text, there'll be no tool calls, and so you just send the user the text. If there are tool calls, you basically need this while loop to continue to call the function, send the result back to the LLM, and then see if that result is a tool call or text. And as long as there are tool calls, you continue this loop of calling the tools until the LLM has run out of tools to call or decided that it's in a good place. And so it's going to stop and return text. So this bit of logic is really concretely what most people mean when they're talking about agents, or at least like the implementation is like, get the LLM to tell you if it wants to call a tool, call the function, pass it the results, do that in a loop. And we can see here this, oh, I didn't actually run this cell. Out of order Jupyter Notebook cells. So we can see here, at least as of the latest update it had, we can see this output here, and it actually includes links to some of the search results. If we wanted more visibility, I can add some prints in here. So let's print like the actual function name and arguments. So we're going to say print calling tool call.function.name with, and then we put in the args here. And this will just give us a little more visibility into the loop. I imagine it's just going to call search once. And yeah, so you can see here the first response, it calls the tool with this query, and then it gets the result. So putting this all together, we have our kind of basic use of the LLM API. We have memory, we have planning, we have tools. Slightly modifying the previous function, I just, compared to this function, added a message history parameter. So this is going to let us pass in previous messages. Besides that, it's the same as the one I just showed you. We combine that with some of the stateful memory bits that we built for the chatbot in this class. And now we can say, hi, I'm interested in AI. And here it doesn't call a tool because it doesn't really need to. It just responds to me. But now I can say, can you find events in Austin that I might like? And here we're, at least I'm trying to prompt it to use both the memory and the tools, because it should remember that I'm interested in AI from the previous message, and then it should use the web search tool to leverage that knowledge in order to give me results that are actually useful. So it is running, and it says, here are some AI-related events in Austin in April 2025. So that's basically putting together the parts of an agent into a concrete Python implementation. Now, in reality, you probably don't want to write all that yourself. So there are frameworks, and I'm going to show you what one looks like. This is called Crew AI. It's a relatively popular framework. So you can set up your agent class. It has a role, a goal, a backstory. All of those are basically fields that are used to generate the instructions to the agent. And then you can pass in tools. It has its own format for tools, but you can basically, it's a decorator. So you can wrap it around a function to turn it into a Crew AI formatted tool. So we have an agent, we have a task, and I made it very simple. It just is get the answer for whatever query I input, and we can run it. The cool thing about this framework, it actually gives you like pretty good visualization if you turn verbose equals true. So we can say like, okay, it needs to find out who's leading, search. Here's like the actual input to the tool. We get the output. It's going to try to find a leader. Oh, it thinks it's 2023. I didn't put the thing in the system message. So that's actually pretty funny. So things that can go wrong with AI agents. 2025. But I mean, there could be a whole nother talk on observability, but this stuff is really useful when you're debugging it to say, well, did it go wrong in calling the tool? Did it go wrong in the results it's got? In this case, it queried for 2023, so that's why I got it wrong. But now we can see this, which I think is actually out of date. But just to go over a couple things at the end here, I've been demonstrating things with one tool, but like really to be useful, you probably want to use multiple tools, because I could have just programmed like a deterministic workflow where I said like, okay, take in the user's query, use an LLM to extract that query, then send that to a search, and so on. So really, agents start to become useful when you can use multiple tools. And so here I've demonstrated a second tool where, in addition to getting search results, it can also fetch the URL and get the text from that URL. So now it's a little bit more powerful. It can actually go onto a page. And here I'm going to say, who is speaking at PyTexas 2025? And here we're going to get a little bit more of an interesting trajectory from the agent. So it first queries speakers at PyTexas 2025. It finds results that are relevant, and then it's probably going to say, okay, I found some information, but it's not detailed, so I need to fetch a URL. So now it's using the second function, and so it didn't find that much information, but it did find that Marietta is giving a keynote, so congrats. So This is something where you'd want to tweak how it's doing it, but this is like a demonstration of how it can compose multiple tools. And I think also a good demonstration of how, as soon as you're using multiple tools, it becomes much harder to control. I can't tell it which pages to go to. I need to make sure I've prompted the LLM to effectively use the tools. Okay, I'm going to skip over the multi-agent for time, but you can see that in the notebook. And then this bit I'll just go over briefly. So since each tool use is just the model picking from a list of things, you can evaluate it as if it's a multi-class classification problem. So here I'm giving 3 functions, and I'm saying, okay, call the function that the user gives you, and I can evaluate it based on if it calls the right one. So if I say, what is my copay for primary care, it uses this function. And I can say, okay, based on my labels, that's correct. In just a short amount of evaluation data, I can say, okay, if I say talk to a human, you should call the function that escalates it. If I say hi, you shouldn't call a tool at all because you should be able to respond conversationally. And so you can use that to evaluate your tool calling accuracy. And this is a key metric that people will use with agents. If it gets more complicated, some things you have to think about are non-determinism. So every time I run this, sometimes it's 80% and sometimes it's 100% in the demos. How to handle actually validating the parameters. So right now I'm only validating, did it call the tool? But I also want to know, did it do the parameters correctly? Oh, it went down 0.6. How to handle multi-turn conversations. Like these are all topics in evaluation of agents that are relevant. Okay, just to wrap things up here. Okay, this briefly, there's no magic to something like Cursor. It is an LLM agent with very good tools. What the team has done well is to describe these functions well to the LLM and create a set of functions that the LLM can effectively use to read and write code. That's kind of the magic behind it and kind of what I'm hoping to show you in this that you could do yourself. Practical tips, describe your functions well. If it has trouble, you can give examples of correct trajectories of tool use. And also performance tends to decline as the tools increase. So if you have like 100 tools with current models, that might be hard. 20 tools it can probably handle. But that's it. Thank you so much for listening. If you want to ask me questions after, here's my social media. Thank you so much.